Hey, it's Mr. Allred, and we are going to graph some functions. We've already talked about parent functions and the transformations that can happen to them. So we're going to do some examples to get a little bit more familiar. So the function we're going to work with here is g of x equals x squared minus 1. So if you look at that, the first thing you might notice is this is an x squared. So that's our parent function, x squared. And what does x squared look like? It looks like the U-shaped parabola. Okay. So if I just wanted to graph this parent function, I could go ahead and put it on and have something that looks like this. Now, the function that I really want to graph or know what it looks like is x squared minus 1. So we want to talk about what is happening to the x squared. And if you look back, this minus 1 at the end is outside of the function. So if you remember what that does, it will shift down 1. So we will take our graph and every point will get moved down 1. Now, I don't expect you to plot every single point perfectly, but in general what we're seeing is we just kind of grabbed the horseshoe and moved it a little bit down. Okay, and when you do these problems that I'm going to ask you to do, I'm going to ask you to identify the parent function, graph it. I may give you two graphs so you could graph them separately, but then tell me what's happening to the parent function and graph the new one. So this is not something I want you to rely on the calculator for, because if we have a proctored test, I may not let you use the calculator at all. Right now, you should be able to use it if you get in trouble or if you need to verify your answer, but don't rely on it as to do the graphing for you. Okay? And I'll let you know if you can use that later. Okay, the second one. F of x equals 2 times minus 1. So the parent function here is the absolute value. So we'll throw that on here. Absolute value is the V-shape. X squared is U-shaped. Absolute value is V-shaped. Two things are happening to this one. And my suggestion, if multiple things are happening, think about what happens when you plug a number in, what order things are calculated. So if we plugged a number in for x, we would first of all subtract 1. And remember, this 1 is inside the absolute value, so it's inside the function. So it's going to move it 1 left or right, but it's going to move it in the opposite direction of that sign. So it's going to shift to the right 1. Okay? And then after you subtracted that 1, you would take the absolute value and multiply by 2. So what I said that will do will stretch vertically. So what we're going to do is we're going to move this thing to the right one, this way is right, and then we're going to kind of close it up a little bit. So this might be a little bit hard for you to do, but the idea is to make it look significantly different in the appropriate way. So we have a V that's been moved to the right and closed up a little bit. Okay. The next one, h of x equals negative square root of x, and then outside there's a minus 2. So anytime I see students deal with a square root and there's something with it, do be careful what that square root is covering. So in this case, we're only taking the square root of x, and then separately, after the square root is completed, we're subtracting 2. When people write these down, sometimes they have a tendency to write it the wrong distance and either cover that minus 2 or not cover it, depending on how it's supposed to be, which makes a difference. So first of all, the parent function is square root of x. That's the one I called squirt. And it looks something like that. And now let's kind of see what's happening to it. So if I plug the number in, I'd take the square root of it, and then I would apply this negative out front. So remember, that negative out front will reflect across the x-axis. And then the -2 will shift down 2. So that's kind of the order we want to do things. Now, if I reflect it, then I kind of have a mess. So let's just kind of move it down 2 and know that it's supposed to be upside down so that when I do it, it'll look something like this. Okay. So reflect it would turn it over, and then moving it down would just kind of take that turned over part down. Okay. Take it in steps. The next example here, g of x equals negative the quantity x plus 1 squared and then plus 3. So taking a look at this, we got good old x squared as our parent function. So that's our U-shaped parabola. Parabolas are a dime a dozen. Then we're going to move over and see what else is happening to that parabola. So let's look at x. What's happening to x? We're adding 1 to it. So that's a left or right. And since it's positive, that's left 1. Then the negative in front of the parentheses will reflect over the x-axis. And then the plus 3 at the end will be up 3. So let's see. Let's take this center point, because that's kind of like our focus. We're going to move it left 1, flip it over, and then move it up 3. So when we flip it over, that center point is still in the same place. So if I move it left 1, flip it over, move it up 3, then it will be centered at -1, 3, and it will be upside down. And I think I made it a little bit wider than I need to. So just be careful there, but that's the general position. Okay. Referring back to the rules from the Rules Explained video and the condensed sheet with all the rules together. Okay, if you need help. Alright, so next one, f of x equals absolute value of x plus 5, and then we're subtracting 2. So no surprise in this one, the parent function is the absolute value. That's our V shape. So we draw a little V centered at the origin. And then with our function, ask ourselves what's happening. X plus 5, that's a left or right. That's a positive, so it's going to move it left. Remember, left to right goes in the opposite direction of the sign, so left 5. Then outside the -2, that's down 2. So left 5 and down 2. And we didn't change the orientation or close it. So it looks just like the original, just in a different place. But you need to write down what's happening, and what you write down should match your graph. Alright, the last example I'm going through, h of x equals the quantity x minus 2 cubed plus 4. So the parent graph here is x cubed. These are a little hard for me to draw sometimes. 2, 4, 2, 4, 6, 8. And then making my parent graph, these are a little rough for me. For some reason, the way the pad is oriented as I try and make it doesn't do me much justice. My cubes look kind of weird drawing them on the pad. You know what that should look like from my graph of the parent graph that was printed out. Let's see here. What is happening to Mr. Cube? Well, x minus 2, that's left or right, and since it's minus, it goes to the right 2. And then on the outside, the plus 4 is up 4. So we'll take this center point, we'll take it right 2 and up 4, and then I'm going to try and draw a nice cube function in that location. So that's some practice. Make sure that you're identifying the right shifts and then graphing it accordingly. I have no problem with you using some type of grapher or a calculator to verify, but don't rely on that as the source of your answers for a heavily weighted test. Okay? All right. Let's get on and do some practice problems.